Welcome to this online training about creating a system design with Platform Designer, formerly known as Qsys. My name is Steve. This training is available for desktop viewing as well as in a format compatible with portable devices, both available from the same link included in your registration email. For either version, while watching the training, use the controls at the bottom and side of the screen to navigate to any point. Feel free to pause the training at any time to experiment with the software. When you are done with the training, please use the link provided in the registration email you were sent to provide us feedback on the training and ways in which it can be improved. I'll remind you about that later. By the end of this training, you will know how to use the Platform Designer user interface to create a system design for implementation in an Intel FPGA device. Along with this, you will see how Platform Designer fits into the Intel Quartus Prime software design flow as another method of design entry. This online training includes a supplemental lab exercise. It includes a lab exercise manual and lab exercise files for use with the standard edition of the Intel Quartus Prime software, version 17.1. If you'd like, you can pause the training here and go to the resources in the upper right corner of this browser window to download these files now and learn more about the development kit required for running the lab design in hardware. Make sure your pop-up blocker is turned off. You may need to hold the Control key to download the files. Before we get started, it's important to understand that there are two different versions of Platform Designer, depending on whether you are using the Intel Quartus Prime Lite or Standard Edition or the Pro Edition. Let's compare the two versions of the tool. When using the Standard Edition, you work with the .qsys file to create your system. The .qsys file contains all the information required to generate RTL code for the system, including all component connections and IP and interface parameters. In the Pro Edition, you still work with a .qsys file, but the file only contains component instantiation and connection information, just the information required to generate the interconnect fabric, essentially turning all components in the system into black boxes. In the Standard Edition, anytime you change any system or component parameters or connections, the RTL code for the entire system must be regenerated. This can take some time with large system designs. In the Pro Edition, component information, which as just mentioned is not stored in the .qsys file, is stored in separate .ip files for each component. Component parameter changes that do not affect the interconnect design can be made in the .ip file, and new RTL code for just the changed component can be generated without regenerating the entire system. In the Standard Edition, every component in the system must be complete and well-defined. Otherwise, the system can't be generated. This includes complete RTL code, completely defined standard interfaces, and hardware.tcl files, which are especially required for custom components. In the Pro Edition, components do not need to be complete in order to generate the system. A generic component that defines the interface connections to the rest of the system without a functional implementation is all that's required. This works well for a team-based design or any system design where part of the system may still be under development. Finally, the Standard Edition interface makes it easy to quickly create, edit, and generate system RTL code. However, with large system designs with lots of components or subsystems, the tool could slow down because the single .qsys file is used for everything. With the change to separate .ip files and updates to the graphical interface, the tool still has the same ease of use, but gives you more enhanced control and better interactivity with the design of your system. Platform Designer in the Intel Quartus Prime Pro Edition software is a huge productivity improvement over the Standard Edition. For this online training, the focus will be on the use of Platform Designer in the Standard Edition. However, all the basic functionality discussed for creating a system design is identical between the Lite, Standard, and Pro Editions. If you want to learn about the unique features of Platform Designer in the Pro Edition, see the Advanced System Design with Platform Designer online training, linked here and at the end of this training. Let's start with a look at how to use the Platform Designer user interface. To start creating a system design in Platform Designer, launch it from the Intel Quartus Prime Software Tools menu. There's also a toolbar button you can use as a shortcut. You can also launch Platform Designer by selecting New from the File menu. From the New File dialog box, select Qsys System File as the design file type to create. If you have an existing Platform Designer system you want to modify, from the File menu, select Open and choose the .qsys file for your system. As mentioned, the basic techniques for using the tool are identical between the Standard Edition and the Pro Edition. However, it's important to note that if you create or open a system design in the Pro Edition, it must be associated with a new or existing Intel Quartus Prime software project. This is not necessary in the Standard Edition. In the Standard Edition, you can add a system design to any project by simply adding the .qsys file as the design file for the project, as we'll see later. In the Pro Edition, start Platform Designer and select an existing project's .qpf file and the desired project revision if the project has multiple revisions. You can also create a new Intel Quartus Prime software project or revision from here. Note that a .qsys file created in the Pro Edition cannot be used in the Standard Edition. However, a Standard Edition .qsys file can be used in the Pro Edition. The Standard Edition file will be automatically converted to a Pro Edition format when it is opened. So if you want to continue working in the Standard Edition, make a backup copy of the .qsys file before it gets converted. Here is an example of the Platform Designer user interface with the main view and tabs visible. We'll look at these in more detail throughout this section. The Platform Designer user interface is made up of a series of tabs you use to both build your system and analyze the results. All the tabs can be enabled and disabled as needed based on the information you need to view. There is a bit of overlap between some of the windows, but many times viewing the same information in different ways and in different formats can increase your understanding of the system and its connections. All of the different views and tabs can be enabled or disabled from the View menu. Click once on the view or tab name in the menu to enable or disable, and a second time to restore the previous state. All tabs are linked together. Performing actions in one tab will affect others, so be sure to check out the many different tabs available to see how they all work together. You can restore all tabs to their default view by selecting Reset to System Layout from the View menu. Click and drag tabs to reposition them. This allows you to customize the user interface to give more prominence to the views you use most often. You can also detach or separate the tabs from the main interface to spread them across multiple monitors. Drag the tabs on top of each other or elsewhere in the main interface to utilize display space more efficiently. Each tab can also be minimized or maximized by clicking on the icons in the upper right corner of the area where a tab is currently located. While Platform Designer will maintain the current tab layout even if you close and reopen the system, you can save the current layout as a custom layout from the View menu. Use the exported .layout file in a different system design, or create multiple .layout files to create different setups to optimize your workflow. Building a basic system design in Platform Designer involves 4 main steps. First, select the components you want in your system from the IP catalog and configure them using each component's parameter editor. The parameter editors provide a graphical tool for selecting each component's optional settings. Next, use the Platform Designer user interface to connect the interfaces for each component together. Recall that a component interface is defined as a standard and made up of one or more signals. Platform Designer will only allow interfaces of the same or compatible types to be connected together. Once you've made the connections, review them to make sure they are valid. All of the necessary connections between components must be made correctly in order to implement your design's intended data flow. Finally, generate HDL code files to represent your system so you can add the system to an Intel Quartus Prime software project for compilation. Let's start with selecting and configuring components from the Platform Designer IP catalog. The IP catalog lists all of the IP that are available and can be added to your current Platform Designer system. A similar IP catalog can be found in the main Intel Quartus Prime software, but IP created from that IP catalog must be manually added to an Intel Quartus Prime project. Standard off-the-shelf IP are listed under the Library section in the IP catalog, and custom IP and subsystems are listed under the Project section. Custom IP components and their creation are covered in more detail in a follow-up training linked to at the end of this training. The IP catalog library section is organized by categories to make it easier to find the IP you need. Just expand the category and subcategories and select the component that you want to add to your system. A very helpful feature is the search field. Use it to filter the IP catalog by name. Just start typing characters and the IP catalog dynamically filters the list as you type. If you know the name of the component you are looking for, you can easily find it this way. You can also filter the IP catalog to only display IP that is compatible with your targeted FPGA device. To add a component to your system, double-click the component name in the IP catalog or select the component and click Add. In either case, the selected component will be added to the System Contents tab discussed in a moment, and that component's parameter editor will open. After double-clicking a component or clicking Add, the component gets added to the bottom of the System Contents tab, and a component parameter editor window opens, allowing you to customize the component for your system design. Each copy or instance of a component added to your system can be configured separately. In the parameter editor, hover over any parameter to see a tooltip for that particular setting. You can see all these tooltips and get access to documentation that provides more details on the component and its parameters by clicking the Documentation button. While the parameter editor will prevent you from selecting incompatible settings, be sure to check the Messages window at the bottom of the editor to see if there are any issues with the parameters you've selected. Click Finish in the bottom right corner of the tool to finish the parameterization and view the newly added component in the system. If at any point you need to change any parameter settings, double-click the component in the System Contents tab. This opens the Parameters tab if it isn't already open. You can also open the original parameter editor window by right-clicking a component and selecting Edit. There are many different types of components you can add to your system. Here's a brief look at some of them. The Basic Components category includes things like a clock source component and a reset source component for managing clock and reset signals entering your system design. Advanced reset components are available for managing multiple reset signals and more advanced control over how the components in your system get reset. Streaming components are used to connect and manipulate the data flows between Avalon streaming interfaces. Memory components include on-chip RAM, ROM, and FIFOs. This category also includes controllers that connect to off-chip memory like flash, SRAM, and SDRAM chips, as well as on-chip DMA components, both regular and scatter-gather. Tri-state components allow you to connect to off-chip devices that use bidirectional data buses, and to share FPGA pins with common signaling for each of these devices. Bridge components allow you to adjust the topology of the Platform Designer interconnect by inserting components such as pipeline stages, asynchronous clock crossing logic, and logic to bridge between 32-bit and 64-bit systems. You can also bridge to other external interface types such as JTAG and SPI. High-speed interface components implement the protocol layers needed for high-speed interfaces such as Ethernet, PCIe, and interlocking. Finally, the Processor Components category includes options for adding processors to your system, such as the Nios 2 soft processor and the ARM Cortex processors found in select FPGA variants. See the Embedded Peripherals IP User Guide, linked here, for a more complete list of available IP components. The System Contents tab displays all of the components and subsystems that have been added to the current system. This tab is your main interface for managing and configuring the system. Use this tab to adjust a component's relationship to the rest of the system, including its connections to other components, its connections outside the system to top-level I/O or other parts of the Intel Quartus Prime project, and its location in the address space of a memory-mapped master interface. In the example shown here, a clock source component, a PLL, a custom button debounce component, a parallel I/O, and a custom state machine component have been added to the system. The Use column allows you to enable and disable individual components without completely removing them from the system. When a component is added to a system, a default name is selected for it automatically. You can right-click the component name to rename it to something more meaningful. In this system, clock, PLL, reset debounce, button switch, and AV SM master are the names assigned to the specific instances of these blocks. Unique names are used to separate multiple instantiations of the same blocks. Next, use one of the many ways available in Platform Designer to connect the component interfaces to each other. When you add a component to your system, the System Contents tab displays all of the interfaces for the component. Each interface is a separate grouping of one or more signals that a component uses to communicate with other components in the system. Most, but not all, component interfaces need to be connected. Some unused interfaces can be left unconnected. This is evaluated on a component-by-component basis. Component interfaces are denoted using dot notation, with the name of the component and the name of the interface. So source.s1 refers to the slave interface named S1 that is part of the component named source. Note that unlike component names, interface names are defined by the component and cannot be changed in the standard edition of the tool. The Pro Edition includes features that do allow you to change interface names, even on off-the-shelf IP. Again, see the Platform Designer Pro Edition online training for details. An important note is that clocks and resets are considered separate interfaces. Clock interfaces are found on all Platform Designer components and must always be connected to a clock source. Unclocked components are not supported. Reset interfaces are found on all off-the-shelf IP and are synchronous to the clock source used for the same component. Platform Designer does not support asynchronous resets. Reset interfaces should be connected to a reset source. However, depending on the design, you may be able to leave a reset unconnected, though the tool will display a warning. The Connections column in the System Contents tab shows which component interfaces are connected and how they are connected to each other. Use the Connections column to quickly and easily make connections from masters to slaves, clock outputs to clock inputs, reset outputs to reset inputs, sources to sinks, interrupt senders to interrupt receivers, and custom instruction senders to custom instruction receivers. The Connections column graphically illustrates existing connections and the connections that are possible between component interfaces. A black dot indicates that two interfaces are connected. An open gray dot indicates the interfaces are not connected, but can be connected by simply clicking on the dot. Based on the parameters selected in the parameter editor and the connections enabled in the Connections column, Platform Designer automatically generates its custom-built interconnect. Other graphical details further assist in making connection choices. An arrow pointing away from an interface indicates that it is a master, clock output, reset output, source, or sender interface. Clicking to select one of these interfaces highlights the connection lines from the interface. black lines indicate a connection to another interface, while gray lines indicate a possible connection. An arrow pointing into an interface indicates that it is a slave, clock input, reset input, sync, or receiver interface. Selecting these interfaces, as shown here, highlights in black the connection lines back to whatever interfaces are connected, and possible connections, highlighted in gray. As you can imagine, the connections column can become very busy when there are lots of components and connections. You can hide connections by collapsing a component's interface. Just click the plus sign next to a component to collapse all of its interfaces into a single line. Additional connection and interface filtering options are available in the System Contents tab and in other tabs accessible from the View menu. Every time you add a new clock interface, master interface, or streaming sync interface to the System Contents tab, a new column line is created in the Connections column to connect other interfaces to it. With very complex systems, the Connections column can become very complicated, making it possible to make incorrect connections. You can use alternate methods to make connections and verify that you've made the correct connections. Right-click any interface and go to the Connections submenu. In this submenu is a list of all of the valid connections for the interface selected. Interfaces with check marks are already connected to this interface. Click an interface in the list to make or break its connection to the selected interface. Instead of the right-click menu, you can use the Connections tab, accessible from the View menu. Select an interface on the System Contents tab. The Connections tab will display a list of all possible connections for the selected interface, using a / character to indicate a possible connection between the selected interface and the other compatible interfaces in the system. Enable or disable the connected checkboxes to make or break connections. In Platform Designer, any component interface in the System Contents tab can be exported. By exporting, the signals that make up that interface are brought out to the top level of the Platform Designer system to be connected externally, either to connect to other parts of the Intel Quartus Prime project or directly to device I/O pins. To export an interface, in the System Contents tab, double-click in the Export column for the interface you want to export. A default name will appear in the form of component instance name _ interface name. You can customize the name if you want. The name will be used for instantiating the system design or for making assignments to I/O pins in the Pin Planner or Assignment Editor. Once exported, the Connections column graphic for the interface changes from arrows and wires to a directional or bidirectional pin icon to indicate this interface's signals are coming into or going out of the system. To turn an exported interface back into an internal system interface, simply delete the exported interface's name in the Export column. Note that a Platform Designer interface cannot be used both inside a system and exported out of the system. This restriction is required for being able to build the interconnect. However, you can use an interface both inside and outside a system by connecting the interface to a bridge component. A bridge component, mentioned earlier, essentially duplicates the connected interface, allowing one of the interface copies to be exported and the other to be used inside the system. See the Embedded Peripherals IP User Guide and other training resources listed at the end of this training for more details on the use of bridge components. This concludes the first part of the training. If you'd like to continue the training, you can register for Part 2 for free at the link shown here. To learn about additional resources available to help you with using Platform Designer, continue to the next slide. To learn more about the basic use of the tool, see the built-in help and the Intel Quartus Prime Standard Edition Handbook, specifically the chapters highlighted here. There are also a number of other related chapters in the handbook that provide more information about more advanced use of the tool. To learn more about the standard interfaces supported in Platform Designer, see the linked documents from Intel FPGA and ARM. Finally, see the Embedded Peripherals IP User Guide for details about many of the off-the-shelf IP you can add to a Platform Designer system. You can also register for a number of free online trainings and 2 full-day instructor-led training classes all about Platform Designer. Use the top link shown here to find all Platform Designer-related classes in our course catalog. One online training to highlight is entitled Platform Designer in the Intel Quartus Prime Pro Edition software. Register for this training to learn about the unique features of Platform Designer found only in the Pro Edition, including the creation and use of generic components. Intel FPGA provides many additional technical support resources besides technical training. Check out the online Intel FPGA forums. They're a great place to connect with other users, to share experiences, and find solutions to common issues. Visit the Intel FPGA Wiki for design examples and up-to-date articles written by field application engineers. Use the knowledge base to find solutions to the most common issues you may run into. Manage your software licenses and online training registrations using the Self-Service Licensing Center. Finally, for local assistance, contact your local Intel FPGA sales office to speak with a field applications engineer. One more thing. When you registered for this online training, you should have received a link to a short survey where you can provide feedback. We'd greatly appreciate it if you'd fill out that survey now. We're constantly updating and improving our training materials, and your feedback helps us create the materials that you want. Thank you for your feedback. My name is Steve, and I want to thank you for taking this training on creating a system design with Platform Designer.